In this new section, we're going to talk about reduced row echelon form. From now on, I'm going to write that as R, R, E, F. Reduced row echelon form. R, R, E, F. What is this? Well, it's a special form that you get the matrix in. And it will be row equivalent to the initial matrix. Okay, how do you change a matrix? How do you get it into RREF form? You perform elementary row operations. Now there are 4 properties that this form needs to have. And the first one is all 0 rows are at the bottom. Are at the bottom. Initially, they may not be at the bottom, but for you to be in RREF form, at some point it has to be in the bottom. What is a 0 row? It's a row that has nothing but zeros. And you should put it at the bottom. If you have this matrix, you should interchange these 2 rows to satisfy criteria number 1. The second one says reading left to right, reading left to right, the first non-zero entry, the first non-zero entry is a 1, or must be a 1. In other words, if you have some zeros, and then the next digit is not 0, and what comes after that can be anything. If it's the first non-zero entry, it must be a 1. If it's a 4, that's not good. The first non-zero entry must be a 1. 0, 1. 3, 4, 0, 1, 2. Reading from left to right. 0, and then not 0. That has to be a 1, and it is. If you have 0, 0, 4, 1, 0, 2, 0, 3, there's a problem here. Because starting from the left, the first entry that is not 0 is the one I circled. But it's a 4. That's the problem. It needs to be a 1. And how do you get it to be a 1? Well, one way is to divide that row by 4. Because we all know 4 divided by 4 is 1. And, okay, now, keep in mind that division is the same as multiplying. One of their elementary row operations is you could multiply a row, let R stand for row, by any number you want, like 7. Now, if for whatever reason you wanted to divide by 7, well, you can't really do that. So, just multiply by a 7s. Dividing by 7, dividing by 7, which is 7 over 1, is the same dividing R by 7 over 1. Well, you keep the R, you change division to multiplication, and you flip over the number. 7 over 1, that becomes 1/7. So when I say dividing, although I really shouldn't say division, I should only say multiplication. But in my opinion, they're exactly the same, and I won't even say that I'm being sloppy. Division and multiplication are the same. Okay. The next one is a bit more complicated. If one row is below another row, then the first non-zero entry, then the first non-zero entry on the lower row must be to the right of, must be to the right of the first non-zero entry in the higher row. Okay, what on earth does this mean? Well, let's look at row 1. 0, 0, 1, 2, 0, 5. That's the first non-zero entry. In the row beneath it, in the second row, the first non-zero entry must be to the right of the 1. That is, it better be 0, 0, 0. You can have more zeros, or you can have the 1 right away. That's the first non-zero entry. In the next row, it better be to the right of the 1 right here. 0, 0, 0, 0, 0, 0, 4. Well, let's say 1. Notice that as I go down, I go to the right. You couldn't have the next row be like this. That's not allowed, because when you go down, you shouldn't find the first one to the left. It should be not here, but somewhere to the right. You have to keep going down to the right. You can't even go right beneath it. You must go to the right. Okay, that's the third criteria to be in RREF form. Okay. There is one more. Now, let's change the terminology a little bit. The first non-zero entry, it needs to be a 1. Let's call it the leading 1. The leading 1. That's the first non-zero entry. Many textbooks and students and teachers, they call it the leading 1. Above and below the leading 1. That is, the first non-zero entry in each row, above and below the leading 1 must be zeros. Must be zeros. In other words, if in the first row, the first leading 1 is where I just put it. Now there is no above the first row. Everything below it must be 0. And of course, to the left must be 0. Why must it be 0? This couldn't be a 1, because the 1 in the second row has to be to the right of this 1 in the first row. The 1s have to go to the right. So for row 2, the first 1 can be here, or it could have been anywhere to the right. Above it and below it, zeros. Now, so that's the leading 1, that's the leading 1, that's the leading 1. Well, there's a problem here, because what's above the leading 1 in row 3 must be zeros, as well as below. I'm forced to put a 0 here, because if I put a 1, even if I put a 3, It's the leading entry, so at some point I'm going to have to divide the row by 3. The problem is the leading one has to go to the right from the previous row. Row 3, the 1 very clearly is here, so it can't be where I'm erasing in row 4. This must be a 0. And maybe the leading one in the last row is right here. Well, that creates a problem because what's above it can't be those non-zero numbers. This matrix right here is in reduced row echelon form. It's in RREF form. You must know these 4 criteria. If you have a row of zeros, they must be on the bottom. If you have 2 rows of zeros, the last 2 rows better be those row of zeros. The first non-zero entry, also known as the leading entry in each row, must be a 1. Those leading ones, as you go down, they have to keep going to the right. And above and below the leading ones must be the number 0. I want to remind you that the elementary row operations are, you can interchange any 2 rows, you can multiply any row you like by a number other than 0, and you can add a multiple of 1 row to another row. So, work out a couple of problems. Suppose you have 0, 1, 2, 0, 0, negative 1, 2, 3, 1, 2, negative 1, 3. You want to get this matrix in RREF form. The first entry in row 1, you really, in the end, you want to have a 1 here. You want to have a 1 here. And if you don't, then the whole row has to be 0. The whole column has to be 0. The reason is you can't have, say, a 1 here. Because row 1, if it's all zeros, it has to be on the bottom. So that tells me that row 1 is going to have a non-zero entry. But it's to the right of this one down here. So what I'm getting at is, sorry to start off with this complicated thing right here, but the first thing you should do in this case is put row 3 in row 1 position. So row 3 goes to row 1 goes to rows 3. So 1, 2, negative 1, 3. The second row we're not doing anything to. Notice how I code what I'm doing. That way when your teacher's grading your paper, if you make a silly error, he or she will be able to realize that it was just an error as opposed to not having any idea what you did. Right. So now, so we go row by row. Row 1, here's the first. Actually, let me say differently. We go column by column. First, we start off in row 1. We have my 1 here, and look at this. I have the zeros beneath it. Row 1 is done. Well, column 1 is done. Now we go on to column number 2. The first non-zero entry is right there. Now, some textbooks and instructors would say you must get that number to be a 1 immediately. Well, the problem is, maybe not so much in this case, but the problem is getting it to be a 1 will involve fractions. Imagine that negative 1 was a 4. Now, if I divide by 4, this is 0, this is my 1, 2 over 4 is a half, or a fraction, and then 3 over 4. Don't worry about getting a 1 in the leading position until the very end. The last step you should do is get the leading 1. Otherwise, you are going to be dealing with fractions all the time. Now, we need to understand some basic arithmetics, or least common multiple. So we want to get this 2 to be a 0. We want to get the 1 to be a 0. And we are going to use row 2 to do that. We are going to use row 2 to do that. Now, ignoring signs for a moment, 2 and 1. The first common multiple is 2. So, if I keep row 1 the same, it has a 2 right there. And if I double row 2, it'll have a negative 2. And if you have 2 and negative 2 and you want to add or subtract to get 0, you need to know what we're going to do. And the only time you subtract and get 0 is if these numbers are exactly the same. And they're not. 2 and negative 2 are different numbers. They're additive inverses. If you add them, you get 0. So that's that operation. Now you have 1 and 1. The first common multiple is 1. Well, if you have negative 1 and positive 1, what do you do to get 0? The answer is you add. So we're going to get rid of this 1 here by just adding rows 3 and row 2. Okay. The second row, we're not doing anything to. The third row, we're just adding rows 3 and row 2. I can do that right here. 0 plus 0 is 0. Negative 1 plus 1 is 0. 2 plus 2 is 4. 3 plus 0 is 3. So that is what row number 3 will be. And notice I got my 0. Now we're going to do row 1 plus 2 row 2's. Well, row 1 is 1. I'm just reading it off. Row 1 is 1, 2, negative 1 is 3. And 2 times row 2, well, row 2 is 0 and negative 1 and 2 and 3. I double those entries. 2 times 0, 2 times negative 1, 2 times 2, 2 times 3. And when I add these, I'm going to call this new row 3. When I add them, I get 1, 0, 3, and 9. Excuse me, new row 1. Like I wrote up in the top right corner, I am putting this result by row 1. So row 1 is 1, 0, 3, 9. Again, I'm not worrying about getting 1s for the leading entries right now, but I do have 0s above and below. Now we go into columns 3, rows 3. 4. That's called, I guess, the pivot number, the pivot entry. I want to get what's above the 4, namely the 3 and the 2, to become 0. Let's deal with the 2 first. The first common multiple, and we're going to use row 3 to do this. Between 2 and 4, the first common multiple is the 4. If I double row 2, I'd have a 4 here. If I do nothing to row 3, that is, I multiply it by 1, for example, I'll have a 4 here. And if both of those entries are 4, upon subtraction, I'll get 0. So that's how I'm going to change row 2. Row 3 is not going to be changed. Now, how do I change row 1? I have a 3 here and a 4 here. The first common multiple is 12. If I triple row 3, I'll have a 12 right here. If I multiply row 1 by 4, I'll have a 12 right here. And if I have two 12s, upon subtraction, I get 0. And like I said, I want to get rid of this 3. That is, I am changing row 1. So I meant to put it here. Sorry about that. Okay, so now let's do this. 3 times row 3, 4 times row 1, then I'll subtract. 3 times row 3. Just triple or multiply by 3 each of the numbers. 3 times 0, 0. 3 times 0, 0. 3 times 4, 3 times 3. 4 times row 1. 4 times 1, 4 times 0, 4 times 3, and 4 times 9, 36. And we subtract. Now, since the numbers on the bottom are always bigger, I'm going to do the bottom minus the top. 4 minus 0, 0 minus 0, 12 minus 12, 36 minus 9 is 27. Now you may say, well, you can't do that. Oops, like I said, I think I said, 4 minus 0 is 4. Now, if you did the top minus the bottom, you would just have negative there. So how can I not have the negatives? Well, one of the rules are, one of the elementary row operations is you can multiply any row by any number. Well, I want to multiply this row by negative 1. So whether you put the positives and negatives, it's not going to make a big deal. Row 1 is 4, 0, 0, 27. Now let's do row 2. 2 times row 2 is, right now, right here. 0, negative 1, 2, 3. Multiply it by 2. You get those 4 numbers. Row 3 happens to be 0, 0, 4, 3. And if we subtract, this gives us 0 like we want. 0 minus 0, negative 2 minus 0, 6 minus 3. 0, negative 2, 0, 3. With the exception of getting 1s for the leading position. This is done. This matrix, other than getting the 1s in the leading positions for each row, this matrix is in row reduced echelon form. The first non-zero entry, in this case, is the 4. What's below it is 0. The first non-zero entry in the second row is the negative 2. And it's to the right of the 4 above. It's to the right of that 4. Because as you go down rows, the first leading entry, the first non-zero entry, must be going to the right. And it did. What's above and below? 0. In row 3, the first non-zero entry is the 4. And it's to the right of the line above. And what's above and below the 4 is 0. Okay, there really is no below. And that's it. There's nothing to comment about in column 4. Okay, now we need to live up to the step that says this leading entry must be 1. So now and only now, maybe I'll get fractions. I'm going to take row 1 and divide it by 4, or multiply it by a quarter. I'm going to take row 2, I'm going to divide it by negative 2. I'm going to divide by that number. You can divide it by the same number. You divide negative 2 by negative 2. Get 1. What do you divide 4 by to get 1? answer. You divide by 4. So, let us do this. The first entries, first row, we divide everything by 4. And we get 27 over 4. The next entry, next row, we divide by 2. Excuse me, we divide by negative 2. And we get negative 3 over 2 for the last entry. For row 3, we divide 0 by 4, get 0. We divide 0 by 4, get 0. We divide 4 by 4, we get 1. We divide 3 by 4, we get 3 divided by 4. This matrix right here is said to be in reduced row echelon form. The first entries in each row that are not 0 are 1s. And the 1s keep going to the right. As I go down, they go to the right. And what's above and below the leading 1? What's above and below this is never anything but 0. What's above and below this 1 is nothing but zeros. What's above and below this leading 1, and is only above, is zeros. Why don't we say anything about column 4? It doesn't have a leading 1 associated with it. Okay, let's do another one. There's lots and lots of arithmetics to do here. Lots of places for errors. 0, 0, 0, 0. 1, 0, 2, 3. 0, 0, 1, 4. And, okay. So we have this. So get this matrix in reduced row echelon form. Well, what I would do is first is put the row of zeros on the bottom. So 1, 0, 2, 3 becomes the first row. 0, 0, 1, 4 becomes the second row. And there is your row of zeros on the bottom. In row number 1, the first non-zero entry is right there. Oh, how convenient. What's below it is zeros. There is no above. Okay. Column 2 is all zeros. That's okay. In row 2, there's your leading 1. There's your leading 1. What's below it is 0. What's above it is not 0. It's 2. So we want to change row 1. I want that to be a 0. Well, the first common multiple between 1 and 2 is 2. And row 1 already has a 2. So I'm going to leave right in that position. So I'm going to leave row 1 alone. I am going to double row 2. Because when I double 1, I get 2. And after doing that, both of these entries will be 2. So then I subtract. Row 1 is 1, 0, 2, 3. 2 times row 2 is 2 times 0, 2 times 0, 2 times 1, 2 times 4. Just multiply every entry in row 2 by 2. And then we subtract. And this will become the new row 1. 1 minus 0, 1. 0 minus 0, 0. 2 minus 2, got the 0 we wanted. 3 minus 8, it's negative 5. So this matrix I'm about to write is row equivalent to the one before. The new row 1 is this. Row 2 we did not change. And row 3 is the row of zeros. This matrix is in RREF form. The row is zeros on the bottom. In row 1, I just circled, and row 2, I just circled the first non-zero entries, and they are all ones, and they go to the right as I go down in rows. And what's below and above this leading one is zeros. What's above and below this leading one is zeros. This matrix at the very end is in reduced row echelon form. Let's try one more. It's very important that you know how to row reduce a matrix, because we're going to solve a system of equations based on this. Suppose you have 0, 1, 0, 2, 1, 0, 2, 0, 0, 1, 2, 3. You should interchange those two entries so this is something other than a 0. So 1. 1, 0, 2, 0. Second row becomes what the first row was. In the third row, we didn't do a thing to. So in the first row, here's our leading entry. And what's above and below is zeros. If there is no above, let's just understand it's okay. It's not zeros. All right, so column 1 is done. Go into row 2. There's your leading entry, your first non-zero entry. What's above it is 0. What's below it is not, so 1. So I want to get rid of it. Well, if both of those entries are 1, if both of these are 1s, and they are, subtract them. You'll get 0. 1 minus 1 is 0. So we're going to do row 3 minus row 2. The first row does not change. The second row does not change. The third row does. We do 0 minus 0 is 0. Row 3 minus row 2. 1 minus 1 is 0. 2 minus 0 is 2. 3 minus 2 is 1. Okay. The second column is now done. There's my leading one in one of the rows, row 2. And what's above and below is 0. Now I go on to row 3. Here is my first non-zero entry. I want to get what's above it to only be zeros. Well, I caught a break. That is a 0 right above it, but that's not a 0. It's a 2. Well, this is a 2, and that's a 2. Subtract, no more 2's. We'll do row 1 minus row 3. So row 3, I'm not doing anything to. I know that. I didn't write anything by it. Row 2, I didn't do anything to. So it's 0, 1, 0, 2. But row 1, I did do a change. I'm doing row 1 minus row 3. 1 minus 0 is 1. 0 minus 0 is still 0. 2 take away 2 is 0. 0 take away 1 is negative 1. Other than getting the ones on the date, for the non-zero entries, other than making sure the leading okay, let's say it again. Other than making sure the first non-zero entries in each row are 1s, we're okay. I just circled the the first non-zero entries in each row. So 1. What's below it are zeros. Here's this one. What's above and below are zeros. Here's another one. What's above it is zeros. No below. And these leading entries are going to the right. Okay. So we need to just do that last step. We need to get the leading entries to be 1. We need to get these leading entries to be 1. Well, we caught a break here and here. They are 1. It's this 2 that we don't like. So we multiply rows 3 by 2. We divide it by half. We multiply by half, or we divide by 2. It's the same. We will divide by 2. But we won't change the first 2 rows. 0 divided by 2, 0. 0 divided by 2, 0. 2 divided by 2, 1. 1 divided by 2 is a half. This matrix is in reduced row echelon form. This completes this section.